Alright, what's up guys? In this video we're going to pick up with a little bit of calculus here, and we're going to be back on the topic of improper integrals. So we're just going to evaluate another improper integral here. So we're asked to evaluate the improper integral from 2 to infinity. We got dx over x times ln of x, or they want us to state that the improper integral diverges. So I got plenty of videos on improper integrals, so if you don't know what they are and how to go about evaluating them, please check out some of my other videos. I don't want to waste too much time talking about improper integrals in general in this video. Let's just go ahead and try to solve it here. Okay, so remember, for an improper integral, since infinity is not a finite value, we can't just plug infinity in. So we have to replace it with a variable, typically t, and take the limit as t goes to infinity of our result. Okay, so this becomes the limit as t goes to positive infinity, and we'll have the integral from 2 to t. I'll replace the infinity with a t, and then we'll have dx over x times ln of x, and that's what we need to evaluate. Now, as I said in previous videos, when it comes to improper integrals, if you immediately know the antiderivative right off the bat, well, then that's half of the work for the integral itself. But if there are some cases where you don't know the antiderivative right off the bat and you need to work it out a little bit, just evaluate the evaluate the indefinite integral first, and then sub in the limits and take the limit as t goes to infinity. So if I pretty much know what the antiderivative to that is, but just in case you don't, we'll actually just go through and actually do it. So we got dx over ln of x. Let's just evaluate this, right? So let's just do a u substitution. Obviously, we pick u to be ln of x. We take the derivative of that, which we know is 1 over x dx. Okay. And then we just get x du is equal to dx. So hopefully you're able to see what we're going to get as our answer. We'll just end up with the integral du over u, which we know is ln absolute value of u plus c. Remember that u was ln of x, so we just have to put that back in there, and we would get ln of x plus c. That's what it would be if it was an indefinite integral. Okay, so now that we've gotten the antiderivative out of the way, we now can deal with our limits. So we got the limit as t goes to positive infinity. Okay. And we got ln of x. It needs to be evaluated from 2 to t. So this will give me the limit as t goes to infinity. And we'll have ln of t. Subtract, I can drop the absolute value bars and just write this as ln of 2, and then we take the limit here as t goes to infinity. And if we take the limit here as t goes to infinity, we'll just simply get infinity minus, well, ln of 2 is just a number, so that'll be ln of 2, and this obviously just gives us infinity. So since we get infinity, that means that this improper integral diverges. So that's the final answer. So our final answer here, the improper integral from 2 to infinity, dx over x times ln of x, this improper integral diverges. And that's your answer. Alright, so that's going to be it. So please check out my other videos for a more detailed explanation of improper integrals. But this is just the gist of it. And obviously I'll continue to post more videos on showing us how to deal with these. Alright guys, I will see y'all next time. Y'all take care.